let's take a look at inverse trigonometric functions. And before we do, let's look at the standard format of a trig function, okay? Just a regular trigonometric function. A trigonometric function, let's call it trig, it could be sine, cosine, tangent, whatever, takes an input that is an angle and it outputs a ratio, okay? So a standard trig function, an input is an angle, output is a ratio, alright? So with inverse trig functions, you simply reverse those two things. So it will look something like, instead of a trig function, you have a trig inverse function, which uses a superscript of -1. Looks like an exponent of -1. Trig inverse of, the input now is a ratio, and the output is an angle. Okay? So for inverse trig functions, the input is the ratio, while the output is the angle. So these are really cool because they output an angle. You can find missing angles using inverse trig functions. But there is an issue. Okay, so let's look at the issue with the inverse trig functions. So for example, so here's our issue. If you take the sine of 0, you get an output of 0. And if you take the sine of 2 pi, you also get 0. And that's because the angle 0 and the angle 2 pi are coterminal angles. And you could probably see that the sine of -2 pi, the sine of 4 pi, the sine of any even pi is 0. So this is one example of the issue. And the reason this is an issue is because this tells us that the sine function, sine, is not one-to-one. It's not a one-to-one function. Meaning, in this case, that many different inputs have the same output. So, in general, functions that aren't one-to-one aren't a problem, but they are whenever you try to inverse them. So if you look at inversing each of these statements, then you get the sine inverse of 0 equals, so now this guy's the input, and each of these is the output. Sine inverse of 0 equals 0, or 2 pi, or -2 pi, or 4 pi, etc., an infinite number of outputs. So this is our problem. For sine inverse to be a function, we should only have one output for each input. Okay? So we have some work to do here to try to make that, to try to force that to happen. Okay? And now there's no particular reason that I picked on the sine function here. You could have chosen any trig function and inverse it, and you'll see the same sort of thing because of coterminal angles. Okay? So how do we make the inverse trig functions actual functions? How do we limit the output of inverse trig functions so that we get only one output? Okay, so here's how I reason it. So you're going to get an infinite number of angles as an output when you do an inverse trig function currently. So how do we fix it? Here's the first thing we're going to do. We're going to choose the angle that requires the least rotation. So in other words, the angle that is closest to 0. That's a natural choice. So for example, if you have an angle that lands here and an angle that lands here, well, to rotate from 0 to the first angle in the shortest distance would be that. To rotate from 0 to the other angle using the shortest distance would be that. So if we have to pick one of those to be the one angle that we want, we're going to choose the angle, the first angle here that requires the least amount of rotation. Okay? So that's just a quick example. Now sometimes if you have two angles that require an equal amount of rotation, if the angles require an equal rotation, meaning they're the same distance from 0, we will choose the positive angle. Choose the positive angle. That kind of breaks the tie. So here's an example of that. If one angle that I want has a terminal side over here while the other angle has a terminal side over here, the least amount of rotation from 0 to the first angle is this, and from 0 to the second angle is this, and you can see that this is a positive angle, this is a negative angle, and the amount of rotation is equal. So in this case we're going to choose the positive rotation. Okay? So that's the idea of how we can limit the output of these inverse trig functions so that we get one output, thus making them functions. I'll make some other videos specifically concerning inverse cosine, inverse sine, and inverse tangent. Okay, the last thing I want to mention here though is notation. So for sine inverse, sine inverse, you can write sine with a superscript of -1. That's read as sine inverse. Or you can write arc sine, A-R-C-S-I-N. Some people like that because you don't use the superscript. It also has a meaning using arc length here. Basically, instead of thinking of the inverse trig functions as outputting an angle, think of them as outputting an arc. Okay, so I won't get into that here because the approach I take usually doesn't involve arc lengths, but that's the idea there. So you could write either one of these. And similarly for cosine inverse, you could write cos superscript -1, or you could write arc cos, and for tan you could write tan superscript -1, or arc tan. Okay, so just a little bit of notation there to finish off this introduction to inverse trig functions.